Chapter 1: The Explosion. There is an explosion in the universe so powerful that, if its beam were aimed at Earth from our galaxy, it could damage the invisible shield protecting life on this planet. And the terrifying part? We might not see it coming. It's called a gamma-ray burst. Gamma-ray bursts are among the most powerful explosions known in the universe. Some can release in just a few seconds more energy than our sun will emit over its entire 10 billion year lifetime. These explosions are so extreme that for a brief moment, they can outshine entire galaxies. But a gamma-ray burst isn't simply a giant explosion spreading equally in every direction. In many cases, the most powerful radiation is concentrated into two narrow jets, and those jets can travel through space at almost the speed of light. Imagine a dying star collapsing somewhere inside our galaxy. Its core collapses, a black hole may form, and in the final moments, enormous jets of energy erupt from the poles of the collapsing object. One of those jets is pointed directly at Earth, thousands of light years away. At that distance, Earth would look like nothing more than a tiny speck in the darkness. But the beam doesn't care how small we are. It travels across the galaxy at the speed of light. And when it finally reaches Earth, our atmosphere becomes the first thing standing between that radiation and life on the surface. Fortunately, the gamma-ray bursts we observe are extraordinarily distant, and a dangerous event would require an extremely unlucky combination of distance, energy, and direction. But that raises a terrifying question. What if one day all three lined up? What would actually happen to Earth? Chapter 2: The Distance. But here's where things become even more interesting. Gamma-ray bursts happen across the universe all the time. Astronomers detect them from almost every direction in the sky. But the vast majority are incredibly far away. Millions, sometimes billions of light years separate these explosions from Earth. At those distances, the radiation has spread across enormous volumes of space before it reaches us. By the time it arrives, it's weak enough to be harmless. But distance isn't the only thing protecting us. A gamma-ray burst is also directional. Its most powerful radiation is concentrated into narrow jets. Think of it like a cosmic flashlight. The light from the flashlight can be incredibly bright, but only if you're standing directly in its beam. If you're outside the beam, you might never know the explosion happened. That's exactly why a dangerous gamma-ray burst would require an almost unbelievably unlucky alignment. The burst would need to happen relatively close to our solar system. Its jet would need to point directly toward Earth, and the burst would need to be powerful enough to seriously disturb our atmosphere. Fortunately, scientists don't currently know of any nearby star that presents an immediate gamma-ray burst threat to Earth. And long-duration gamma-ray bursts appear to be relatively uncommon in galaxies like the Milky Way, so the odds are extremely small. But the Milky Way is enormous. It contains hundreds of billions of stars. And somewhere inside that enormous galaxy, massive stars are being born, evolving, and eventually dying. Most of them will never affect us. But imagine that one day, one of those stars reaches the end of its life, and its final explosion happens to point directly at Earth. What happens next? Chapter 3: The Impact. Now imagine it actually happens. A massive star collapses somewhere inside the Milky Way. A black hole forms, and an enormous gamma-ray jet erupts directly toward Earth. The radiation travels across thousands of light years at the speed of light. For the people on Earth, there would be no visible object approaching, no giant fireball in the sky, no warning in the atmosphere. The first sign would be the radiation itself. Gamma rays would slam into the upper atmosphere with incredible energy, and our atmosphere would immediately begin absorbing that energy. Molecules of nitrogen and oxygen would be broken apart and transformed through a chain of chemical reactions. One of the most important consequences would be the formation of nitrogen oxides, and these chemicals can attack ozone. The ozone layer is one of Earth's most important invisible defenses. It absorbs much of the sun's dangerous ultraviolet radiation before that radiation reaches the surface. Now imagine that shield suddenly becoming damaged. The gamma-ray burst itself might last only seconds, but the atmospheric chemistry it triggers could continue for years. In one scientific model, a powerful nearby gamma-ray burst caused roughly 35% global ozone depletion. At some latitudes, the depletion was even greater, and that means the real disaster wouldn't necessarily happen during the burst. It would begin after the flash was already gone. The sun would still rise every morning, but more ultraviolet radiation would reach the surface. Plants would be exposed. Marine organisms would be exposed. Entire ecosystems could begin experiencing stress. And once the foundation of an ecosystem starts to weaken, the effects can spread through the food chain. A few seconds of radiation, could create consequences lasting years. And this is where the story becomes truly frightening. Chapter 4, the aftermath, but the damage wouldn't stop with the ozone layer. The atmosphere would have changed. The chemistry of the entire planet could begin to shift. As nitrogen oxides accumulate in the atmosphere, they can interact with sunlight and alter how much radiation reaches Earth's surface. The sky could become darker and take on unusual colors, and the climate could begin to change, but the most vulnerable systems might be hidden beneath the ocean. Phytoplankton are microscopic organisms that form the foundation of many marine food webs. They need sunlight to survive, and they are extremely sensitive to changes in their environment. If increased ultraviolet radiation damaged large populations of phytoplankton, the consequences could spread through the entire ocean ecosystem. Small organisms feed on them. Larger animals feed on those organisms, and eventually, the effects can reach the largest predators in the ocean. On land, plants could also face increased ultraviolet exposure. Crops could be damaged. Forest ecosystems could be stressed. And as food production becomes less reliable, the consequences would eventually reach human civilization. But here's where scientists have found something fascinating. Earth may have experienced something remotely similar before. Around 440 million years ago, during the late Ordovician period, one of the largest mass extinctions in Earth's history occurred. Around 85% of marine species disappeared. The exact cause is still debated. Scientists have proposed dramatic climate cooling, glaciation, changes in sea level, and other environmental factors. But another possibility has been investigated: a gamma-ray burst relatively close to Earth. If such an event had damaged the ozone layer, increased ultraviolet radiation could have placed enormous stress on marine ecosystems. It could also have triggered atmospheric and climatic changes. This idea is fascinating, but there is an important distinction. Scientists have not proven that a gamma-ray burst caused the Ordovician extinction. It remains a hypothesis, a possibility written into the history of our planet, but not a solved mystery. And if a similar event happened today, the consequences could be very different. Because unlike the creatures of the Ordovician, we have billions of people depending on a highly connected global civilization. Chapter, would we survive? So, would humanity actually go extinct? The honest answer is, we don't know. A gamma-ray burst would not simply vaporize Earth. Our atmosphere would absorb much of the initial radiation. The greater danger would come afterward. A damaged ozone layer, increased ultraviolet radiation, stressed crops, damaged marine ecosystems, and a food chain under enormous pressure. But humans are remarkably adaptable. Some populations could survive. Underground shelters could provide additional protection. Food could be stored. Agriculture could potentially be adapted. And unlike the creatures of ancient Earth, we would understand what was happening. We would know that the danger came from space. We would know that the radiation had passed. And we would have technology, science, and years of warning from the changing environment to respond. So a gamma-ray burst might not be the instant extinction event we imagine. It could be something more terrifying. A fight to keep civilization alive after the universe has already pulled the trigger. And fortunately, the chance of a nearby burst aimed directly at Earth is extremely small. But the universe is enormous. And sometimes, the most dangerous events are the ones we never see coming. Outro. A gamma-ray burst could remind us of something humbling. Earth is not isolated from the universe. We live on a tiny planet, protected by an atmosphere we rarely think about. And thousands of light years away, a dying star can unleash an explosion powerful enough to change that protection. Fortunately, a dangerous gamma-ray burst aimed directly at Earth is an extremely unlikely event, but the possibility tells us something incredible about our universe. Some of the most powerful forces in existence don't need to reach Earth physically to affect us. All they need is a clear line of sight. So the next time you look up at the night sky, remember, every star you see is part of a much bigger and much stranger universe. And somewhere out there, explosions are happening that make our sun look almost insignificant. This is Cosmic Truths. If you want to explore the universe's most extreme events, cosmic mysteries, and the questions that make us look at space differently, stay with us. Because the universe is full of stories, and we've only just begun to uncover them. See,